Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. This is the 6th installment in the Adventures with Python series, in which we learn Python by building a text adventure game. No prior programming experience is needed, but you should watch the series videos in order. I'll link the playlist here and in the description. Let's get started. So far, we've built a game with a data structure representing our dungeon and a game engine composed primarily of a loop, allowing the user to explore the dungeon until they choose to quit. We also noted that there's some redundancy in the data structure, and we took a step toward remedying that by writing a program that will take a list of exits and turn it into a string that we can display to the player. This is a much better solution for two reasons. One is that you want to avoid redundant data storage because the data can get out of sync if you update one representation, but forget to update the other. The other is that the exits can change. Rooms can flood, doors can be unlocked, beavers can build dams, so it makes sense to keep track of exits in a way that's easy to modify. It's easy to add or remove exits from a list. Knowing what string to swap in would be more complicated. In this video, we're going to see how to incorporate our generateExits string code into our game. I've renamed our game as shabbyabbyv5.py. I'll upload this to my GitHub repository with the other code from this series. There's a link in the description. The first thing I'm going to do is restructure our Abby data structure and change the program constants accordingly. Let's get rid of the exits string for each location. And rather than leaving the directions as individual integers, I think it will make more sense to put them in a sublist. So I'm going to wrap a list around the direction integers, and now our constant exits with a value of 2 references the list of exits. And I'll set north to 0, south to 1, east to 2, and west to 3, the indices of those values in the new sublist of exit integers. I'm going to temporarily comment out that line of code that prints the exit string, since it's no longer there. And down where we're setting the location index, I'm going to remove +north. That addition was to offset the direction the player typed so it would index correctly into the location. Instead, we're going to be indexing into the sublist, and the sublist is parallel to the directions list, so the index will be correct without an offset. I will have to change the next line of code, therefore, to index into the sublist of direction integers. I'll write if Abby sub current location sub exits sub location index is not equal to -1, indexing first into the current locations list, then the exits list within that list, and then the direction that the player wants to move. And immediately after that, if it wasn't -1, we'll also change the code that sets the new current location to current location equals Abby sub current location sub exits sub location index. Those adjustments are just to work with the new structure of our dungeon. If I run it, you can see that it functions as before, except it no longer tells me the exits from my location. We'll need to add that back in, but with our code that generates the exit string from the list of exits. We could do that by pasting in the code from our generateExits string program where I have the commented out line of code. But we'd be adding in a lot of code that is doing one thing, creating a string from the list of exits. It would be better to have that code somewhere else and keep our game engine uncluttered. The way to do that is by writing a function. A function is a block of code with a name. We execute the code by using the name of the function. We call this invoking, calling, executing, or running the function. After the function code executes, control returns to where we called it. We already call built-in functions in our code, print and input. That code is long and complicated and would clutter our program if we had to type that code in every time we needed to display something to our player or have them type a value in. It's also code we use many times, so it makes sense to write it only once. That way we don't risk introducing an error when we reuse it. The other advantage to functions is that they can be specialized with parameters. The print and input functions don't print the same thing every time. They allow us to specialize what they display to the user with a parameter, such as welcome adventurer, or you're in the plus Abby sub current location sub name plus period, or I didn't understand that command. Finally, they can return values to where they're called, the result of their work. The print function doesn't return anything, but input does. It returns the text the user typed. Let's turn our generateExits string code into a function. In my program, after the constants, I'm going to write def, all lowercase, and then after that, the name of the function. I'll call this function getExitsString. And notice I named that all lowercase and with the words separated by underscores, just as we do for variables. I then put parentheses and a colon. Inside the parentheses, I put the parameters, the data that I'll need in the function to make it work. What I'd like to do is generate the exit string for a specific list of exits. That might look like 1, 2, 3, 4, or -1, -1, 0, -1, for example, the exits from the cloister and the garden, respectively, but it could be any list of integers. So I'll pass in the list of exits, and getExitString will return the string that says there is an exit to the east, or there are no exits, or whatever matches the list passed in as a parameter. I can call that parameter whatever makes sense for the function. I'm going to call it exitsList and annotate it as a list of int. When we call this function, we'll be passing a list in as an argument. So when this function starts executing, that list will have a value already, the value that we should generate a string for. This function will return a string. That's the result of its work. I indicate that by putting a dash close angle bracket after the close parentheses of the parameters list with no space between. It looks like a little arrow. And then I'll put str, the data type of the value being returned. Now inside, indented, as you may have guessed, I put the code. We've already written this code. Let's see how we might need to change it to fit our function. We can ignore the testing loop and begin where we have a value for exits list. That's where our function begins, with the exits list that's passed as a parameter. We will copy and paste in the code that creates a list of exit text and then turns that list into a string we can display to the player. That's lines 53 to 62. I'm going to add an annotation for the variable exit string. Our code uses a list called directions string, which is a list that's parallel to the directions and includes the strings in order, north, south, east, and west. Let's make that a constant, and I'm going to change it from a list to a tuple. A tuple is like a list, but it's immutable, meaning it can't be changed in the code while the program is running. A tuple is delimited by parentheses rather than square brackets. In fact, I'm going to make that change for my other constants as well. This is just a little added protection to keep our constants constant during program execution. By the way, it's added protection against us forgetting and writing new code that breaks our current code. Now, in our program, we then printed the generated string along with the expected string for testing purposes. Here, we want to return the string to where the function is called. The string is the work product of this function. At the end of the function, we add return exits string. This ends the execution of the function and returns the work the function did, the string that was generated. If we don't have a return statement in a function, the function will end execution with the end of the indented code, but it won't return any data. All of its data will disappear. Not all functions return data. The print function doesn't, but most do. Most functions take some input as parameters, do something with the input, and return the result. We need to return data from a function because no other part of the program can access the variables that are internal to the function. This is related to a concept called scope that is important to understand, but can be difficult for beginning programmers to grasp. I'm going to link a playlist here and in the description that goes into detail about writing functions, including the concept of scope. For now, if you follow the pattern of passing in the data a function needs as parameters, and returning the work that the function accomplished at the end of a function, you'll write successful functions. We have now defined a function. That associates the name getExitString with this block of code. But it won't run. It's just defined. Let's look at how to invoke this function. We want this code to run when we want it to run, and using the data we want it to use. Down in the game engine, we have our commented line of code that used to print the exit string from the data structure, the one we removed. We'll uncomment that now and rewrite it to invoke our function, getting the exit string from the function. So print, because we want to print the value that's returned, and then we use the name of the function getExitString. Now we'll need to pass in some data. What does the function expect? It expects one value, a list, which is the list of exits. We want to pass in the list of exits for the current location. That's Abby sub current location sub exits. That's it. We've invoked the function, passing in the list of exits for the current location. What will happen when the program is executing is control will jump to our new function. Our exits list will be copied to the variable exits list, and then the code will execute, generating a string from exits list. It then returns exits string. Control will return back to where the function was called, and the function call will evaluate to what the function returns. So the function call getExitString evaluates to the string that was returned from the function exitString. We can put this function call anywhere in a program that we can put a string, because this function call will evaluate to a string. So I can put it as an argument to a print statement, and the string will be printed. Or I could assign it to a variable. Or I could include it in a different expression, like a concatenation. Now let's restructure our entire program so that it's composed of functions. A common name for the function that is the starting point of program execution is main. I'm going to write def main arrow none colon under the getExitString function, and then indent the rest of the code under that function header. Now my entire program is broken into two functions, getExitString and main. I've defined two functions, but I haven't called main, so if I run the program now, it will do nothing. I need to tell Python to run main, so at the bottom of the script, I'll write main. That invokes the main function. The order may seem odd to you, but you must define functions before invoking them. So I'm putting the definitions at the top, and then invoking main at the bottom. For many languages, including Python, this is the standard structure. Define a function before you invoke it. Now if I run my program, it works as before. This is not the standard way to call main, though. You might have seen this code in Python scripts if you've been exploring Python programming on your own. If _ name _ equals open quote _ main _ close quote colon main. We'll invoke main that way. The reason we invoke main this way, rather than with simply main, is because scripts can be imported into other scripts, or they can be run as a program. If we write this at the bottom, then we can write another program that imports this script to borrow some of its functions, like the getExitString function we just wrote, without having this script accidentally start running. If we just write main at the bottom, the script will run if we try to import it. So that bit of code distinguishes between the script being run and the script simply being imported, and runs main only if the script is being run. And just as an example, I have a script here, which is our testing code, separated into a new script called testGetExitString.py. I've imported shabbyabby v5.py, and I'm testing the getExitString function. So I can write a little testing program to test my function, import my script, and test it without having the game engine run. Now, to document a function, we should put a docstring under the function header. A docstring, remember, is 3 quotes, multiple lines of description if needed, and then 3 more quotes. Under my getExitString header, I'm going to write generate and return a string describing the exits from the list. That's what this function does. If a function returns a value, it's a good idea to say what that is in the docstring. For main, I'm going to write obtain and process commands from the player until they choose to quit. Now, I'd like to add a little more functionality to this game, so I'm going to rename what we have as shabbyabbyv6.py, and I'm going to show you a pattern that will follow every time we add a new command to the game. I'd like to add a look function to the game. Up in the constant section, I'm going to add a look commands constant, another tuple, and I'll put L and look in the tuple. Down in the game loop, I'll add to my if-elif structure that processes commands. After if command in directions and the conditional code, I'll add elif command in look commands, enter. And I'm going to invoke a function we haven't written yet, print getDescription, open close parentheses. What I'd like is a function that does this work rather than handling it right here. That way the game loop stays short and easy to read. Now the function is going to need to know the current location, so I'll pass in Abby sub current location. I'll write the function now. I'll write this below getExitString. The keyword def And then I must use the same name I used when I invoked it, getDescription. In parentheses, I put the parameter. This is going to be the list describing one location, so that's a list of strings and a list. I'll call it location, and then of type list, string or list. And this will return a string, the description of the location. I'm going to annotate a variable called description of type string. I'm going to return the name of the location, then a new line, and then the description. So description equals location subname plus a new line plus location subdescription, and then I'll write return description. And instead of just printing the name of the location at the top of the loop, I'll get the description there too and print that. Let me run that. It says cloister, and then on the next line, you are in a courtyard. That's the description. If I type L or look, it repeats that, cloister, you are in a courtyard, and then it displays it again. That's because every time we complete command processing, we come back up to the top of the loop and display the current location. Here's how I'd like to change this so it feels a little less repetitive. I'd like to keep track of the number of times the player visits a location, and only display the description if it's the first time visiting a location. Otherwise, I'll display the name only. And in the look command, we'll display only the description. So first, we'll need to keep track of how many times the player visits a location. Let's add that to each location's list. I'll put a 0 at the end of each list, because they all start out unvisited. And create a constant for that, visits and int equals 3. That's the index in our list. Where I annotate this data structure, I'll change the annotation to list, string, or int, or list. Now, in getDescription, I'll check that field. If location subvisit equals 0, description equals location subdescription, else description equals location subname, and then we'll return description, as before. And down in the game loop, I'll increment that visits count after we've gotten the description with Abby sub current location sub visits plus equals 1. Now I'll run it, and it tells me I'm in a courtyard. I'll go north, and it describes the church. Now I'll go south, and I'm in the cloister. No description, just the name. I'll type look. Uh-oh. Now it says cloister, cloister, because I've been here before. So I'd like to pass in another parameter that tells the function I want the full description this time. So if the player types look, I get the full description. That can be a Boolean, because it's really just on or off, true or false, full or brief. I'm going to pass a true here. Now, up in the function, I'll add the Boolean parameter. To have more than one parameter, we separate them by commas. So comma long of type bool. And in the function, I'll check if long or location visits equals 0. So if we get a true passed in, we'll give the long description. Or if this is the first visit, we'll give the long description. And otherwise, the description will be just the name. Now, there's something cool we can do. We can give this parameter a default value of false. To do that, I'll put equals false up in the parameter list after the parameter annotation. This means I don't have to pass in an argument when I call the function. And if I don't, it will be assigned a default value of false. But if I do pass the argument, the value passed will be used. If you're going to add default parameters to a parameter list, they have to come after parameters that don't have a default value. Down in the game loop, I'm not going to add an argument for long where I get the description at the top. So the default value of false will be used, and we'll have the same behavior we had before, long description if the first time only. Let's run this. Again, I'll go north, south, and then I'll type look. That's less repetitive, and it's better behavior. A lengthier description only the first time we visit a location, or if we ask for it. Okay, so that's our entire program organized into functions. Write a function when you have code that you might reuse so that you're writing and maintaining it in only one place. If you give your function a meaningful name, it'll simplify your code while keeping it readable. You can specialize functions through parameters so they can solve a class of problems, like generating a string for any combination of exit, or returning a description for any location with any number of visits, but also taking into account that a long description might be desired. I recommend rewriting our functions from scratch, looking back at the video only when you get stuck. For a little side project of your own, write a program with 2 inventory lists, one for a location and one for a player. Write a function that will take an item from the location's inventory and put it in the player's inventory, but only if it's there. Write a similar function that will drop an item from the player's inventory, again, only if it's there, and add it to the location inventory. Look at the similarities in those 2 functions and figure out how to rewrite them both as one function that does both. Do this with careful parameter passing, not an if statement. You might also watch the functions playlist linked in the description for more examples of functions and in-depth discussion of the concepts of parameters, return values, and scope. When you're feeling confident with functions, join me for the next installment of Adventures with Python. As always, have fun and keep coding.